Hello, hello. Today we're learning about stretch and compression. We know our absolute value graph, but how does it stretch wider? How does it stretch taller? So if it goes taller, that's called a stretch. If it goes wider, it's called compression, like you're pressing that down. We know that our x squared quadratic parabola is that U shape, but does it stretch steeper? Does it compress down and get pressed down wider? And we're going to do that with all of our graphs. And how do we turn that into an equation? So we're going to roll right into it with that red graph over there. Y equals, we know that's the absolute value graph. We know that shape, right? So we got the absolute value bars. That always gives us that V shape for that absolute value. But now we're looking at the stretch factor. This one's not shifted up or down. It's not shifted left or right. But if you look, it's skinnier. It got stretched taller if someone grabbed those arrows and pulled that up. So how much is it stretching? It's easy. You take a look at your vertex, boom, right there. You simply go over one spot to the right, and then you tell me how much do I need to stretch to meet the next point on the graph. So when I go one spot over, I'm going to have to stretch up a +1, a +2, a +3. You put that out front. What it's technically doing is multiplying. You won't always see that little dot, that little multiplication sign, but it's 3 times as tall as the absolute value graph. So that's literally what you're writing. It's 3 times as tall as that absolute value graph. Cool, we're going to head on over to blue. We know this is the square root graph, so I can go y equals. I leave a little blank for the stretch factor out front here. And this one you can see is also stretched taller. How do we find that? We go to our key point on the graph. We go over one spot, and then you see how much do you need to stretch to hit the graph. Stretch up +1, +2. This is also a stretch of +3. So it's 3 times as tall as our normal square root graph. All right, so that normal curve, I don't know if my mirror is, the video is backwards to you, but we got that square root graph. It's simply 3 times as tall. Cool, we take a look at the green one. We actually, if you were here in class yesterday, we had a quick example of this, but we know this is our x squared. We know that's our quadratic. We know that's our parabola, but this one got flipped upside down. So sometimes your stretch or compression also involves a flipping or a negative number, and all you do is you head to your vertex, you go over one spot to the right, and you count how much do you need to stretch to hit your graph. We got to go down 1, down 2, down 3, so this will be a -3 stretch. That's how we get our quadratic to flip upside down, as having a negative stretch factor. Cool, we'll head to the page, and we're going to start to combine a little bit of everything that we've learned in this chapter. So some things that you might want to do before you just go ahead and write your equation down right off the bat is go, this one is shifted up to. And the stretch, when I go over one spot, it looks like it's up half. So my stretch is 0.5 or is 1/2. Cool. I know that is the absolute value graph. And it is up to, as we learned earlier in the chapter. And the stretch is 1/2. So it's going to be 1/2 or 0.5 times our absolute value graph. Cool, so we're putting everything together here. Y equals, we know this is our cubic graph, but if I take a look at this cubic graph, that key point has actually shifted to the right 2. It is shifted up 2. And it has a stretch. When I go over one spot to the right, it looks like it is stretching down 2. So my stretch is -2. So your stretch factor is always going to come out front. That's -2 times. And then I have this x cubed graph. It might help, because x cubed doesn't have grouping symbols. It might help to just give it some parentheses. So I got my stretch of -2. I can check that off or underline it. The up 2 is easy. That's always at the end, up 2. The right 2 is a little tricky. So to the right 2 means that my x is at +2. But if I'm in the group, remember we learned that that's opposite, because we always have to solve that equal to 0. So if I want x equals 2 to be an answer, x minus 2 is going to take me to 0. And hopefully you already passed that level, you passed that lesson, So that hopefully is not new to you today in this video. On our last one in the red one, we've got y equals, and we have a graph we have not seen before. This one is actually the square root, but it is upside down, which is fine. We don't have to do anything with the upside down. That will be covered in our stretch. What is our stretch? When we go over 1, it's stretching down 2. So that upside down, that just means that our stretch has a negative, and it's a -2. The key point, how do I get to that key point? That is right 1. And it is up 3. So I got a lot of things I got to consider here. So I'm going to go ahead and always do that stretch first. Y equals -2 times, and then we got the shape of the graph, which is square root of x. So I got the square root covered. I got the stretch of -2. This time I'm going to focus on inside the x, and the x is left and right on the x-axis, right? Left and right on the x-axis. It's going to the right 1, which means x is +1. But remember, whenever we have a grouping symbol in Algebra 2, it's like we got to think 0 or solve how to get to 0. So if I want this x to be at a +1, think about plugging in 1 minus 1 will take me to 0. It'll take me to that key point. And then it is up 3, so once that square root is done, then I just put a +3, and I have finished that. If you got any questions, please ask. This might be the trickiest part, combining all 3 of these, but I would just like to get you to focus on what our stretch was today. So again, find that key point, go over 1 spot to the right, and then see how much you have to stretch to hit the graph. Down 1, down 2, so my stretch was -2. Find the key point on the graph, go over 1 spot. How much do I have to stretch? Down 1, down 2, until I hit the key point on the graph. The stretch was -2. Find the key point on the green graph. Go over 1 spot. How much do you have to stretch to hit the graph? That is a 1/2. And if the decimal one was a little confusing there, we can talk about that a little bit more in class if we really need to find those exact numbers.